Study with Steph, cause she's the best. She's gonna help you get your CTS, yeah.
Ain't nothing can keep me down.
Stephanie.
Hey everybody, welcome to another episode of Study with Steph. On this episode, it is going to be one that everyone has been requesting since I started doing this. And joining me is Rebecca Sullins of Pro Media Audio Video. And she's also the chair for the CTS Certification Steering Committee. So thank you for joining me.
Thank you for having me. I have a vested interest in people learning this stuff since getting more people certified.
So I felt like you were going to be a really good person to help me with this. So this is where we kind of go over a few of the formulas that you may possibly need for the CTS test. This is the AV math episode, which is like very scary to me. I felt really good about it for a while, but I have not cracked those notes open in a while. And when I did, I was like, I no longer know what this is. So
math scares a lot of people for a lot of different reasons and has since grade school. It's once you understand the basic concepts and sort of learn what they're talking about, it becomes a lot less daunting.
Yes, like I like started to remember some things. I was like, oh yes, aspect ratio. I could totally calculate this today. That's not that bad. And then as like before we were recording this, I was like, yeah. And now we're getting to like furthest viewer and like image height and like all of these like things that I like totally forgot about and like doing the sound calculations. And I'm like, oh my gosh, this is gonna be kind of hard.
Yeah, it's and they're making it harder as more and more people get into technology and we rely on it more and more and it becomes more nuanced. The calculations to do it also become more nuanced. It used to just be, you plant the farthest guy 8 times the image height away from the screen and you're fine. And it's a little more complicated now that we use technology for so many different things and in so many different ways.
So should we start with like aspect ratio? Because I feel like that was easy.
Sure. Aspect ratio is probably the easiest. And it's something that, most people are wildly aware of. Most of them are pretty standard: 4x3, 16x9, 16x10, which is the most common these days. And if you're still using 4x3, tell someone to pony up some dough and get some new equipment.
That's Zack Snyder. He's still using 4-3.
I mean, so just to throw in this little nugget of information, the reason that we have gone away from a 4x3 aspect ratio is because we have 2 eyes and they're side by side. We literally see left to right more easily than we see up and down. So our brain can take in a lot more content laterally than it can vertically. And so a 16x10 aspect ratio is actually more natural for us to look at and more comfortable. Yeah.
And so to calculate the aspect ratio, that is just your width divided by the height.
Yep, exactly.
That is just W divided by H. That is the easiest probably math.
That is the easiest one to do. And it can be displayed either as a ratio, as in 4-3, 16x10, whatever, or it can be given as a whole integer number, like 1.78 is 16.9 if you actually do the math. So you may see it one of 2 ways. And if you don't remember, like if you see 1.78 and you're like, oh, I don't remember which one that is, just go to your calculator, divide 16 by 9 and see if it comes up right? There's only so many actual aspect ratios that we use in everyday life.
Perfect.
So you can figure those out pretty easily.
When it starts to get a little trickier, it's when we're looking at the screen diagonal, correct?
Yes.
And
it's still pretty easy.
If you took high school geometry.
Yes, high school geometry, the Pythagorean theorem. Pythagoras was a brilliant man. And in order to figure out the diagonal, it's literally a squared plus b squared equals c squared, which is the height squared plus the width squared equals the square of the diagonal.
And so then you just take the square root of it to get the like number that you need normally.
Exactly.
Think, right?
And so the easiest one to do that everybody can do in their heads is going to be 4x3. If you have a screen that is 4 feet tall, and always remember to keep your units consistent. I know that this is AV math and we should know this, but double check your units and make sure they're all consistent. So if your screen is 4 feet tall or 4 feet wide, 3 feet tall, whatever, you're doing 9 plus 16, the square of 3 plus the square of 4 equals 25. The square root of 25 is 5. Your diagonal is going to be 5 feet.
Mm-hmm. And then, yes, I've just kind of memorized, like, I think that for the test, I tried to memorize those. So I memorized that 4-3 was 5, 16-10 was like 18.87, and 16-9 like 18.36.
Yeah. And a quick checksum to make sure you're doing your math right. The diagonal is always going to be longer than either of the sides. So if you get a number that's smaller, you've done something wrong.
Something's wrong. Yes.
Yeah.
But so can you give me an example of when I might need to like use a conglomeration of that formula? Because I feel like sometimes you don't need the diagonal, like you'll be given the diagonal and you'll need to find like the height or the width.
Now this is where it's going to get a little bit tricky because that does happen a lot, right? Screens are often spec'd by their diagonal size.
Right. Which took me like a long time to realize, like when you're buying a 50-inch TV, it's not like 50 inches side by side.
You would be shocked how many people still don't know that. And like every sales guy at Best Buy will tell you that. Like if they know it, everybody should, but that's okay.
Yes.
So that is where it gets a little bit tricky because let's say you've got a screen diagonal of 100 inches, and I'm just using something that's easy to math here.
Okay.
Excuse me, 100 inches. The height and width, if you need to back calculate that, you also need one other piece of information. What do you think it is?
Another piece.
The aspect ratio. Because a 100-inch diagonal screen will give you 3 different size screens based on 3 different aspect ratios. So you have to know if you're working with a 16:9, a 16:10, or a 4:3. Just to make this easier, let's assume it's a 4:3 aspect ratio.
Okay.
Then it's actually going to get a little bit complicated because, let's see. So if we know that 4:3 gives you a 5 diagonal, then you have to proportionately derive out the rest of your numbers. So to get 5 to be 100, we've multiplied it by 20. So multiply the rest of your numbers by 20. You're going to get an 80/60. And that keeps your ratio the same.
Yes. This is where you like cross multiply. Yes.
So I'm not going to lie. One of the cheats that I have found to do this, and a lot of people in AV have the ability to do this. In AutoCAD, I will literally draw a square that's 16 units by 10 units, right? Scale it up so that the diagonal equals whatever I want and then measure the sides. Because that's faster for me than doing the math. But I don't think they let you do that on the test. So it's important to remember to factor in your aspect ratio and remember that all the numbers need to stay proportional.
Okay. That makes sense. Yep, I am.
Okay, so so this is something that you could do to do this actually relatively easily. And I may need to like draw this out for you and send you my notes. But
I know what
you're cross multiplying. You have 16/9, which means you know the C. So whatever the C is, that's going to be your 18.36, right?
Yes.
So you cross multiplied your 9 with your 90 and then divided it by your diagonal
and that's
to find
your height.
Exactly. Yeah. So that works.
That's the way that my brain is going to have to understand that, unfortunately.
No, that's another great way to do it. Like me, I just look at all 3 numbers and I just raise them proportionally and drop them down in my head. But for some people, the way you did it with cross multiplying so that you have a definite constant to compare against makes more sense. Yeah. So if you know that the image height of a 16:9 screen is 9 and the image diagonal is 18.36, what we're doing here, listeners, is we're putting 9 over 18.36 is equal to X over 100, right? Is that what? No, 90, excuse me, 90. So then you're cross multiplying 90 times 9. And if we remember cross multiplication, you multiply the bottom by the top on one set and then divide by your third number and it keeps that ratio the same. So then your image height is 44 and a half inches.
Yes. Okay.
So that makes perfect sense. Yes.
I'm going to have to include pictures like in the description of this episode so people know what the hell I'm talking about, which is,
I was about to say, we may need to go back and listen to this and write some of these problems out.
Yeah.
So that visually we can make a little
Like
more sense and include a little
know what I'm talking
handout.
about.
Yeah.
Yes. Okay. So let's try another one that I just like do. Okay. So let's say this is a 4-3
Okay.
screen. The diagonal is 27.5 and I want to find the height.
So we know that the diagonal of a 4-3 is 5, right? Because we already did that math.
You're right.
And we're trying to find the height, right?
Yes.
So if we take 5 over 3, right, which is the diagonal over the height for a known proportion,
yes,
is equal to our diagonal of what weird number did you give? 22.7365 or something?
22.5.
27.5.
27.5.
So 27.5 over x. So 27.5 times 3 is, and this is where I'll break out my calculator because I'm just not a glutton for punishment. And mostly just because I don't like being wrong when I'm being recorded.
5 times 3 it's 82.5. And then we're going to divide that by 5. And so that is a width of 16.5.
That is exactly correct. And then if we want to find the height, we can either take that 16.5 and multiply it by 1.3 to get your 3 up to 4 proportionally.
Yes.
Or you can do the exact same thing you just did. 27.5 times 4 equals 110.
Yes. But I feel like once you have 2, it's just so much easier to plug them into the Pythagorean theorem. And then you can just get your third one.
Yeah, and you absolutely can. I generally find it easier just if I've already got the other formula written out. All I have to do is replace that 3 with a 4.
Yeah.
And do the exact same thing I just did. But either way works just fine.
Yes.
And that'll give us a width of 22.
Yes. I feel like the only thing that's gonna maybe catch me on this is I need to just make sure I'm clear about what variables I'm using. You know, make sure that because I feel like it's really easy to get confused. To make sure I'm using D for if I'm trying to figure out the diagonal, H or W.
Yes. Or if you're using the Pythagorean theorem and it makes it easier for you, use A for the height, B for the width, and C for the diagonal, because then it always relates back to the one that we know and love to spout off. Yeah.
Yes. Okay, perfect. I feel better about this. This is making it easier. Okay. So next up, I feel like Ohm's Law was the next easiest for me just because it's you can memorize it really easily.
You absolutely can. You can also do what I did for many, many years and print out that giant circle with all the little pie pieces, right? And just stick it on your wall and it's always there.
It's always there. It's not there on the exam. They don't give you that. I wish they did. I wish they were
do they not?
No, you have to memorize it.
They used to.
Yeah, they don't like that anymore.
So I feel like I should know this. I'm the chairman of the committee that signs the thing when you pass the test. I feel like I should know.
No, that's fine. If I pass my exam this time, I'll try to join the committee since I've taken it recently. I can help.
There you go. You should. I think I joined right after I got my dual certification. And some of the test questions absolutely peeved me off to no end. And I was like, we need to fix this.
Yeah. No, some of them also. Yeah. I was like, this is not for people to pass.
Yes.
Sorry, Avix, if you're listening to this. Love you so much.
No, we love you. I volunteer on so many committees for them. I love them. But sometimes things need to be changed. And that's okay.
Yeah. So, okay. So what Chuck taught me is the pi in my ear. I don't know if you're familiar. So it's if you can see that, the P over IE and my E over AR.
Okay. That's interesting. Okay. So I'm going to write this down and see if I can make it make sense. Because here's another thing for anybody else out there listening. People will use different letters to represent the same thing depending on which version of the formula you're looking at.
And that's the worst part. And so and I'm just a mnemonic device person, so like I have found P over IE, E over AR to be the most helpful to me.
Okay, so that's going to be watts equals I times
volts.
Amps times volts. And see, now that one I learned is the West Virginia law. W equals VA.
Oh,
West Virginia, because it's watts equals volts times amps.
yes.
And that's something that that a lot of people can remember as well. So whichever mnemonic device works for you. And the other one,
volts,
which is volts equals
over amps times ohms.
Amps times ohms, resistance. Yes.
Yes.
I learned that one as a slightly less politically correct version.
Okay.
So the I was referred to as Indian. But the idea is E, electromotive force, which is volts, right?
Mm-hmm.
And then R for resistance. And again, see, we're using you can use all sorts of different things, but I and A can often be the same thing. Yes. So, and it was the Indian shoots at the rabbit on the ground and shoots at the eagle up in the air. So that's how you could remember where they went on your little triangle.
Okay.
But again, it's whatever works for you. And then I learned that one in the West Virginia law, and that's how I always remembered it.
Are those the only like configurations that you need to like know for sure? Because the rest of them you can just solve for, right?
The rest of them, yes, you can derive based on those three things. Or based on those four variables. You use your basic transitive properties, because division multiplication is all transitive. So you can move them around to make any formula that you need to find whichever variable you're looking for your particular problem.
So yeah, for me, it was just easier to do pi in my ear and then just kind of memorize what each of those variables would be measured in.
Yes. And that's another thing where you've got to make sure that your units are correct.
Yeah.
I've definitely seen test questions where they'll try to trip you up and put something in millivolts or, some random crap like that. So, always verify your units first. But yes, you can move those four variables around into any combination, any formula that you like to find what you need.
Yes. So I want to double check what each of these is measuring before we go further. Okay. So P is like power. That's like watts.
That's yes. And that's power consumed. That's your actual usage, what you're actually using. Watts on a light bulb, higher wattage, it's using more power, brighter bulb.
Okay. What does E volt? I know E is volts, but like what does E measure?
Electromotive force, which is the technical definition of the word volt. So, or electromotive potential. So trying to get back into the basics of electricity just a little bit. If you think about a water hose, okay? And this is the easiest way for me to understand it, because a lot of people don't really understand what voltage is. Because you can have, you cannot have current without voltage, but voltage does not equal current. Okay. So in this particular analogy, like a water hose, there is always potential. There is pressure, there's water pressure, but nothing's actually moving, right? So until you turn on that spigot, i.e. plug in a load, and you can hear my Southern come out when I say the word spigot instead of spigot, but my husband makes fun of me for that. So until you plug in a load or turn on that water hose, nothing is actually flowing, but the potential exists.
Okay.
So that's what the voltage is.
Okay. And then I is impedance, right?
Yes. And yes, exactly. Also referred to as resistance, although, and we might get some hate mail over this. I don't know how many people listen to this podcast, but if there are some uber nerds on there, impedance and resistance are not technically exactly the same thing, but for our purposes, they are.
Okay. So then what is R in the equation? Because that's ohms and that's not resistance.
Oh, no, I apologize. In this one, I is amps.
Yes. And what is I?
Which is current. It's flow.
Oh, I forgot that one's weird.
Yeah, that one is weird. And that
They
one gets
messed me up.
And you absolutely, dear listeners, will from time to time see resistance noted with an I as well. That's why I say make sure you know what your acronyms are.
This is the worst. So I is current, which is amps.
Mm-hmm.
R is actually resistance, which is ohms.
Mm-hmm.
And then, so then in the ear one, what is A? A is measured in amps, but what does A stand for in this equation? Because it was I in the other one.
Honestly, I think it's just amps. Let me make sure of that.
Okay.
But I'm guessing they're doing that to make the acronym work.
Okay, that's fine.
So that it's easier for you to remember your mnemonic device.
That's
So we've got volts equals what times resistance. Yeah, that's ohms times amps.
Okay.
Yep.
All right.
I'm sorry. I thought I'd turn my phone ringer off. Y'all are
No, you're fine. I couldn't even hear it.
Today. Oh, good.
Okay. So can you give me like an example and I'll try to solve for it?
Ooh, okay. Let's see. If you are working in a standard US power system,
Okay.
I'm giving you a clue about 120 volts here.
Okay.
And your let's see. Your amplifier is pulling 1800 watts. How many amps do you need? How many amps do you need on your circuit to power that?
Okay, hold on. It might take me a while.
That's fine. And this is one where the West Virginia law might be easier for you to remember what is what.
Okay.
Because that's the way specs are more often given to us is watts, volts, and amps.
Okay. Watts, volts, amps. Okay. So then it's going to be. Okay, I got 15 amps.
That is correct.
Yes. Okay, perfect. So I forgot that you could do this, but when you do the pi in my ear thing and you know the one you want to solve for, you just cover it up. And then that gives me watts over volts.
That is correct.
And then that was the answer. So
that is
yeah,
correct.
I will make sure to include that picture for anyone who like wants it. But okay. And so it's going to be useful for me to remember that 120 volts is standard in the US, right?
Yes, it is.
Okay. And do I need to like memorize the European standard at all? Or
no, okay. no. Because Avixa, one of the things that's been happening over the last 5 years is with their accreditation and their international growth is they have had to become a lot more inclusive with other regional standards and stuff like that. So there are certain things that they won't ask you about anymore. Okay. And if they do ask about something like that, they're going to tell you the voltage.
Okay. Okay, cool. While we're like keeping with voltage, and can we briefly take a look at some of the sound calculations now? Because
Sure.
So those are the log. So thankfully we do have a calculator on the CTS test because I don't even know how to. What does log even stand for? Is that logarithm?
Logarithmic, yes. It is a logarithmic equation, which means it's more similar to exponential than linear, if that makes any sense, but logarithmic, I believe, has to do with a factor of 10. So let's see. Constructed so that successive points along an axis are an equal distance apart, represent values which are in an equal ratio. So it's getting bigger, but at a consistent ratio. And we use 10 log and 20 log a lot in audio.
Yes.
So it's either getting bigger with a factor of 10 or bigger with a factor of 20.
And the only formula that we need to know that's bigger by a factor of 10 is the power one, if I'm not mistaken.
Decibels is 20 for sure, because sound likes to work in.
Yes. Is that what you're calculating for in these equations? Or do these give you like in this 10 log PV over PR? Is this like what is it giving you?
All right, let me take one step back because this may open a can of worms.
Okay, that's
the word decibel has nothing to do with sound.
That's right. It doesn't measure anything. It's just like a comparison, right?
Exactly. You could technically have 3 dB of giraffe, or whatever the plural of giraffe is. I don't know. Giraffes, I guess. It feels like one of those words that would get weird when you pluralize it, but maybe not.
So then
but
when
a
you're
decibel
turning
is a
something,
ratio.
yes. So when you're turning something up, you're turning it up each time by like the 10 more. Like
Exactly.
the 10 logarithm more or something.
Exactly.
Okay.
The difference between 2 decibels and 4 decibels, what we actually hear is the exact same between 40 decibels and 80 decibels.
Okay.
Doubling is doubling, right?
Okay.
So, and that's where this gets a little bit weird. But decibels for power is, again, just sort of measuring power as a ratio.
Okay. So there are like 3 versions of this equation. There's the one for power, the one for voltage, and the one for distance.
Okay, so the one for voltage is trying to give you a decibel change for voltage.
Yes.
Honest to God, don't think I've ever actually used this outside of a classroom setting.
Oh.
Because voltage is relatively consistent unless you're installing audio in, war-torn Ukraine.
Yes.
But it is giving you a ratio. And so, that the decibel formula for voltage is that's going to be a 20 log. And it's giving you, if it's positive, it's an increase in voltage. If it gives you a negative number, it's a decrease in voltage.
Okay.
Same thing with power, only it's measuring a change in wattage.
Okay. And then the distance is just measuring like a length.
Yes, it's giving you a change in length. Yes,
Okay.
that's the easiest way to explain it.
Yes, I know that's
Without
not
getting
like that's not like the
pedantic and over explaining.
That's
right.
not like the AV tweet way to explain it, but that's just gonna have to be okay for today.
Not everybody likes to listen to AV tweets. Nobody takes me to concerts anymore at all because I just,
So basically the way that these equations are, that's like obviously like you're gonna have a calculator, you're not gonna have to do like logarithmic stuff in your head, but it's like either
Thank
10
God.
log, yeah, I know, or I'd be screwed. I would just be like, you know what, I actually don't need a CTS.
Yeah, I was telling Steph before this that my college professor made us learn how to do this on a slide rule, so I could still possibly do that if you gave me one, but I don't even think you can buy them anymore.
Yeah, so I don't think. Yeah, okay. So then you have basically like a reference point and then a variable point.
Yes.
And I believe on the test, they are always going to give you both of these.
Yeah. Or they will give you some way to find out,
Yes.
what that is. I.e., you may very well reference a previous question where it said, hey, take your furthest viewing distance that you just found and find the different, the dB change in just whatever. But yes, you will be given that information. Working a logarithmic equation backwards is not something that you would be expected to do.
Okay. Thank God, because I was like, I don't even know where I would begin to do that. So
yeah, I took calculus in high school for an easy A, and I don't even remember like how to start to go back and do that.
Oh, that was an easy A for you. That's
math.
Cool.
Math has always been my easy one. Always.
I think I did statistics as mine. Okay. So can you try to give me some way to like how this would be worded to me so that I could maybe try to figure it out?
Oh, okay. Oh Lord. Again, this is not decibels for power is not one that I use very often. This is why we associate decibels with sound, because that's where it's used. Let's see if I can find a all right, let's use another thing that's relatively commonly measured in decibels would be something like power at an antenna, right? What you're actually picking up from a transmitter. And this is going to be, the math is probably going to be a little bit weird, but let's say your initial measurement was 100 watts. You were outputting 100 watts. Okay. And that's what the antenna was outputting, yada, yada, yada. And then all of a sudden, everything stops working and you take another measurement and all of a sudden you're getting 0.1 watts, 0.1 watts. What's your decibel change there? And this is another one where they would try to probably trick you up and put in like 100 milliwatts. Oh. And you need to convert that to watts.
Yes.
because nobody says 0.1 watts.
No, they don't. Okay. So variable one, I'm going to say is the 0.1.
Mm-hmm.
And then the reference one is 100.
Uh-huh.
So I'm going to say that this is 10 log. And then it's going to be 0.1 over 100. I got minus 30. So that's minus 30 dBu, right?
Yes.
Yeah.
Mm-hmm.
So that
dBu
means
is usually for power. dBV is voltage.
okay.
dB SPL is sound pressure level. That's what we think of when we think of how loud things are. You're actually measuring in dB SPL. And there's actually two different ways to weight those. So sometimes that can become important. I know that this is all just about doing the math, but when you're looking at specs, you need to make sure that you're using dB SPL A weighted or whatever to remain consistent.
So when it's negative 30, like when it's a negative or a positive number, like what does that mean?
That means you've gone
down. Okay.
Right. And that means that you did your reference versus whatever correctly, because I told you the first time we measured this, we measured it at 100 watts, and now it's gone down 30 dB to 100 milliwatts.
So if I had gotten some positive number, like that wouldn't have made sense. Because
exactly. That means you did it backwards.
Okay. Cool.
Mm-hmm.
Okay.
So yeah, and that's a really good thing. And actually, this one's another really easy one, and factors of 10. Because this particular logarithmic equation is a 10 ratio, if you take 100 and move the decimal point over 3 places, as in 3 times 10, you get 0.1, right? So we know we did that right.
Okay. Great. That's a good one. That's a good one to check. I feel pretty comfortable with this because I feel like as long as you memorize the formula and like, okay, the first time you did this, you got this number and you can recognize like which one's your variable and which one's your reference point.
Yep.
You can plug the rest of it in.
Yes. Yeah. And that's the biggest thing with a lot of this is making sure you put the proper number into the proper variable and then just look at your answer and see if it makes sense. Like if you're getting 4,800 dB positive and the question is asking you, oh, why did the power suddenly stop working? That should probably be a negative number, right? Like just look at your answer, see if it makes sense. And with all test taking, that is the first thing that I tell everybody, eliminate any possibility that just absolutely doesn't make sense.
Doesn't make sense.
And that's a good rule of thumb with math.
And the next thing that you're going to have to be able to do is just make sure you understand like which equation to use, because the power one is the only one that is a 10 log. So I think that you're just going to have to look at what you're measuring. So you knew that we were measuring watts, and so that's like a clue to use the power one.
Exactly.
Yes. What would be one where like they would ask about voltage?
I mean,
because you said that one is the one that you just do not really use much.
It's not one that I use very much because, in this day and age, generally, if I've got a problem with voltage, I'm just going to start by measuring the voltage and seeing where the problem is. I don't need to know how much the voltage dropped. I don't care about the ratio from 120 to 97. I just need to figure out where the problem is and get that 97 back up to 120 because that's where it's supposed to be.
Okay.
Not something. There may be some very specific things for a video if a video something requires a specific voltage or anything like that. But
that makes sense. And distance is like obvious because like it's I'm your units that you'd be measuring a distance in. Okay.
Right.
So when it comes to just what should I memorize here so that I will not choke when I see these questions?
The biggest thing for me, I will go ahead and tell you, as a general rule, I am anti-memorization. Because it doesn't do you any good. And there are so many numbers and random acronyms that if you memorize one single thing wrong, one single number, one single whatever, guess what? You're done, right? Because all of a sudden that's going to bleed into every other calculation that you do. I personally much prefer to you don't need to memorize these formulas. They're here, right?
Yeah.
Ohm's law is important. And your pi in the ear, good, but we already found a problem with that. They use both A and I to refer to amperage, right?
Mm-hmm.
Which could be confusing. So if you're going to memorize Ohm's law, pick a version of it that uses the same acronyms for everything and memorize that, or at least memorize the two versions of it so that you can then derive any other combination that you require.
Okay.
That one is good because you don't need to, like, that one is so simple that there's no need for you to waste time going back and forth between your test and the sheet and the test and the sheet, right?
Yeah.
That one should just become second nature.
Okay.
But any of the other more difficult things, don't bother memorizing them.
Okay.
Just because it's better for you to take the extra 10 seconds to verify that you're using the correct formula than to get the entire question wrong and possibly subsequent ones as well.
Okay. I guess my last question for you would be, what are like a few test taking tips that you would suggest to me this time around?
Okay. My biggest test taking tips, and I'm an expert test taker. I was a lackluster student at best, but I got like a 1500 on my SATs and I slept through the first half of it. Like, I love taking tests.
I'm a bad test taker. I'm the opposite.
I'm a great one. I love it. So the first tip is, what I do when I take a test is I like to go through the test as quickly as possible and do everything that I know right off the top of my head. Right? Because there's going to be some questions that are really, really simple, i.e., you have a amplifier on 120 volt service that needs 8 amps. How many watts is it pulling? Stuff like that. You can do that basic math in like 2 seconds. And that's why I say, maybe memorize the two components of Ohm's law, because those are going to be the simplest calculations you do. You can rattle them off your head just like this. And those are the ones that you'll use most often in your career. We always have to spec power. We always have to spec, stuff like that. So go through as fast as you can, do everything that you know immediately. Then go back to the ones that you didn't know immediately and start from, most of these are multiple choice, right? I think that, in fact, they're all multiple choice now.
They're all multiple choice.
I took this when you could still take it online. Like, that's how long ago I took the CTS.
Yeah, I know. Those were the days.
I know. I'm old. I'm old. I'm talking about slide rules and taking the CTS non-accredited and stuff. Oh, I'm going to go get a fake hip after we're done here.
Nah, it's okay. I think my boss got his before I was born or something. So it's
cool. Wow.
Yeah.
I was only the fourth woman in the world to ever be dual certified. Like, that's how long ago I've had these things.
Jeez. Okay.
So, anyway, I apologize.
No,
but they're multiple choice. There's always going to be at least one answer, possibly two, that are just absurd and immediately incorrect. They're distractors, and they're easy distractors. That's what they're actually called. And just eliminate those.
Okay.
That's a big one. And then go back and look at what is the best answer.
Because if I do that, I can usually at least get it between one and the other.
Right. And if nothing else, it, gives you a better chance. Because, they always say, if you don't know, just pick C, which is statistically not prescient. Right. But,
yeah.
But, if you can cut down your statistics, statistics, if you can cut your options down from 4 to 2, better odds.
That's better odds. Okay. Anything else you think I should do to prepare?
Let's see. So I actually am one of the item writers for the CTSD exam. Oh, so cool. I can't tell you too much here.
That's okay.
But a big thing is just make sure, and this is something that I tell my daughter all the time, because she's getting to that age where she's really smart and she just reads through the question, picks an answer that looks correct, right?
Yeah.
If you're not 100% sure, read through the question twice and just take notes of keywords, right? Because that will often, a big thing with all multiple choice tests is, select the best answer. There might be two that are kind of right and that you can kind of argue for, but one of them will always be better than the other. So if you're unsure, go back and look for those keywords that may point you towards one or the other.
Okay. Well, Rebecca, thank you so much. I appreciated this. This was a lot of help for me. You
You're
have no
welcome.
idea. But yeah, I hope I pass this time around so that I can, join the number of people who have a CTS. But I'll be sure to let you know.
Yeah. Good luck to you. And if you
Thank you.
do pass this year, it'll be not my signature on your certificate, so you can hang
Oh
it
my
on your
gosh.
wall.
Full
It'll
circle.
be fun. That's right.
Perfect. Well, thank you so much. And to everyone listening with Study with Steph, you can, of course, listen anywhere you find podcasts or on YouTube or on rAVe Pubs. And I will, of course, make sure to upload the pictures of my notes, although they are really scary looking. And I'll make sure to try to point out where you can find the calculations and stuff. So thank you, everyone. And thank you again, Rebecca.
Thank you, Steph.
Study with Steph, 'cause she's the best.